Alright, so I got a small update for September. Back on the power supply. Still working on it. We've got the voltmeter installed, and it's just when you get off the counter kind of thing. I had to make a board for it. So here's the meter board, and we've got the 100K divider chain, and then this is the sense. So when we sense 18 volts, it kicks over to the high voltage range. In the low voltage range, we have 2 sig figs. In the high voltage range, we have 1 sig fig. Now this has onboard power, so from the old system board, we don't really need these transformers anymore. And the system board, the old system board's kind of blowed up pretty good here too. We didn't anticipate the huge load currents that we were dealing with when we were pulling full load from the 5 power supplies that are all in parallel. The other thing we're going to do, hopefully, is we're going to change over from this donut, which has a little bit of loss to it, to this filter when we're there. We're not quite there yet, but this is a 50 amp rated choke. I'm hoping this will help with the RF suppression. So we'll move from the one that's in there to this one, and that's on the to-do list, as well as get the current meter going. So that's not there yet. I've got more of these inside, but I need the power and the divider and all that other good stuff. We also have a local remote. So these are your sense. This is your power. So in local, these guys are directly connected to the outputs, and remote, of course. Then you have to have these connected, or it's going to go nuts. It'll try and adjust its voltage feedback, and it'll go crazy. So I need to put some protect resistors in there, a few meg ohms, what have you, in order to protect that from going crazy. We have a delayed turn on, which is nice. So this is the delay. So we have a thermistor in there that helps us do a pre-charge, so we don't flip the breakers continuously and blow up traces on the boards. So we're going to turn it on, and she'll do her delay, and then the light will come on saying, hey, I'm good to go. There it is. She's good to go. So she's good to draw power now. There's 20 millivolts on the terminals. This design always has some residual voltage on the terminals. I'm thinking about how that can be dealt with, but at this moment, that's not a concern. I could care less. I'm just going to increase this. So you see we still have 2 sig figs. There we go. So we went over to the next range. So now we've only got 1 sig fig. And we have to do that because we only have 1999. We have 200 millivolts for this, for these meters to read full scale. So we have to make maximum use of the readout that we possibly can. there's our 40 volt output, and we don't have any current right now. The load's not hooked up. Load's right there. We're not hooked to a load. So that's seeing what's on the terminals right now. There's 40 volts right there. So that'll give you a bad hair day. I'm gonna crank this down. Now we only have a 100 ohm bleeder resistor on this right now, so it takes a little bit of effort for this guy to discharge because he's got a lot of capacitance. So it takes a while. But there you go. So some of these boards will be integrated, hopefully, into one master board. We don't need both of these now, since we're using 12 volt supplies. We're only using 5 12 volt supplies, so we only need 4 range controls. We don't need 8. The main board will have to be redone, and some of the control board layouts will have to be redone as well. But the voltmeter board, this is good to go. So that's where we're at for September, and I think we're doing okay. But I really need to wrap this up. And this is just a prototype. This is just a shell for the prototype. This isn't the finished product. The finished product will be in a better rack box, which I already have. This is just to get all the bugs worked out.